Go. I am Mr. Bishop, the guy in the Bitmoji right there. This is Chapter 2, Day 4. We're going to be talking about solving systems of equations with matrices and how to move forward with doing that. For starters, let's refresh about what a system is. So I'm just going to get two linear equations here, put my curly bracket on the left-hand side there to demonstrate that these two things are related to each other. Right? The x and the y from these two equations are the same. So we've seen these in algebra, right? Algebra 2, Algebra 1. We've dealt with systems of equations. We've solved them with substitution, elimination. Well, now we're going to move forward with solving them using matrices. So we know we have a system of equations. We need to progress to putting that into a matrix, and that's going to be an augmented matrix is what we'll call it. So it looks like we have three different terms in the first row for the first equation. So I'm just going to put 3 blanks and 3 blanks in the second row. And we've got 1x, so I'm just going to put a 1 for the coefficient, 4 y's, so I'm going to put a 4, 3 x's here, and negative 2 y's there. So I'm just going to put the coefficients, no more x's and y's once I get to the matrix form. And then I've got a 14 and a 0 for those terms. And notice I changed the color. And where the equal signs were, we're going to put a vertical bar to represent the equal signs. So in purple there, we just want the coefficients, right? The numbers attached to our variables. And then over here in green, you can think about these as being sort of like the answer column, right? They're not really the answers necessarily yet, or the solutions by any means. But for now, let's think about those as being the answers. They just have their own column. And then this vertical bar, again, represents the equal sign. Right? So over here we have equal signs, over here we just have a vertical bar. And that is our augmented matrix. So that's the first skill in being able to solve systems using matrices. We take a system of linear equations and put it into an augmented matrix. Notice there's no more x's and y's, just the coefficients and the answer column, and you've got a vertical bar that separate those where the equal signs used to be. So an augmented matrix comes from a system of linear equations. Let's look at another example of this. So I'm going to give you 3x minus 4y equals negative 6. So that's just one linear equation. It's not a system yet. We need at least 2 linear equations. So I'm going to give you one more. 2x equals negative 5. And I've got my curly bracket here so you know that they're associated. So all I want you to do at this point is be able to express this in an augmented matrix. So I'm going to make a little arrow here. I'm going to make a matrix. Let's see. It should have 2 rows because I've got 2 equations. And it should have 3 columns. And then I'll put a vertical bar for the equal sign. So I've got 3 x's, so the coefficient I'm going to put a 3. Negative 4 y's, I'm going to put a negative 4. 2 x's here. Notice there isn't a y in this equation, or you might say there are 0 y's here, right? So we'll need a placeholder, excuse me, for that y. I'm going to put a 0 there for the y because there isn't one on this lower equation. And then I've got my answer column there, negative 6 and negative 5. There you have it. There's our augmented matrix. Let's look at one more that's a little bit different. So I'm going to give you 3 equations this time and 3 variables. So we've got 2x minus y plus z equals 0 for the first equation. The second equation, x plus z minus 1 equals 0. And then the third equation, x plus 2y minus 8 equals 0. And I'll go ahead and make my curly bracket here too. Alright, so in putting this into an augmented matrix, it looks like we'll have 3 rows because we've got 3 equations and probably 4 columns there right? So I'm going to go ahead and make a matrix, put a vertical bar where the equal signs were. And if you haven't noticed by now, we've got these things organized so that we've got a column for the x's, a column for the y's, a column for the z's, and we have the answer column over on the right. Okay, so I've got these spaced out accordingly. But then if you look closely at the way this system is presented on the left, it doesn't quite align such that we can copy and paste necessarily into this matrix the way it's written. Although the first equation is easy. I mean, it's x, y, z, and then the answer column. So for the first equation, we have 2 x's, negative 1 y, 1 z equals 0. So that one's relatively straightforward. But if you look at how the second equation is organized, you'll notice not only is there no y term, so we'll need to put a 0 for the y, but this negative 1 is sort of in the way. There shouldn't be any floating constant terms over here at this point. This should just be for the x, y, and z terms on the left-hand side of the equal sign. But not to fear, we can easily handle that negative 1 by just adding 1 to both sides and moving it over there to the right. And then we'll just have our x and z terms over here on the left. So I'm going to add 1 to both sides. That way it shows up on the other side and not here. And if you can't visualize it, that would just become x plus z equals 1. And that's what I'm going to copy into the matrix. So I have, excuse me, 1 x term, no y terms, 1 z, and now I've added the 1 over to the other side, so I have a 1. And now it's organized such that I can put it into the augmented matrix. And we have a little bit of the same issue with the third and final equation here. There's no z term, so we know we'll put a 0 as the placeholder for z, but this negative 8 doesn't belong on the left-hand side, right? We'd like to put these in standard. Any constant term like this should be added over to the right-hand side. So let's go ahead and take care of that. In this case, that negative 8, we're going to add 8 to both sides. That way it goes away on the left-hand side and shows up on the right-hand side. And then when we express that in the matrix, we've got 1x plus 2y, so I'm going to put a 2. There is no z term, so I'm going to put a 0 where the z would be. And then since I added the 8 over, the 8 is going to be in the answer column. All right, there you have it. X, Y's, and Z's, and our answer column organized into an augmented matrix here. Let's look at one more example along these lines. I'm going to give you an augmented matrix to start. So 3, negative 1, 1, and 5 in the first row. In the second row, 2, 0, 6, and 2. And you might have a pretty good idea of what I'm going to ask at this point before I even ask it. Now I'm presenting you with an augmented matrix. I'd like you to convert it to a system of equations. In other words, put this into XYZ form. Well, now we know how these augmented matrices are organized. We have our X's in this column, our Y's in this column, our Z's in this column, and our answer column. So as long as we keep that organization and that structure, we should be okay. So the first equation would be 3x minus 1y. You don't have to put the minus 1 if you want. You could just write minus y. Plus 1z. Right? And if you just want to write plus z, again, that's fine. Equals, from the vertical bar, 5. There's our first equation. In the second equation here, we have 2x. I suppose you could write 0y if you want. I'm going to ignore it since there is no y term here. But there is plus 6z equals 2. So there you have it. That's another skill that we'll need, being able to go from an augmented matrix to a system of equations. In other words, like we did here, let's go back to XYZ form. Alright, so in this video, we talked about how to set up an augmented matrix from a system of equations. In the next video, we're going to move forward with actually solving these systems using these augmented matrices. So that's all for these notes.